Hello, in this video I'm going to be going over Lewis dot structures of covalent molecules, and these are a little more difficult ones than the ones that we've been doing. And some involve resonance, some involve polyatomic ions with a plus or minus charge. We have this first one, SO2, and I'm going to do this the old way, which makes it more confusing, and then I'm going to go over it a different way that should make it less confusing. So we have SO2. Sulfur is the one in least supply. We have just one sulfur, two oxygens, so sulfur is in the center. And looking at our periodic table, sulfur has 6 outer electrons because it's in column 6A, or 16. So we have 1, 2, 3, 4, 5, 6. We have 2 oxygens. I'm going to put them where we just have 1 electron, so it can make a nice bond. And oxygen's in the same column as sulfur, so we have 6 outer electrons. Form bond. 1, 2, 3, 4, 5, 6. They're going to form a bond. And as you can see, we have 2 electrons that are not bonded. You cannot bond them this way. The only bonds are going to be between the outer and the center atoms. So what we have going on here is resonance, and what resonance is a double bond forming at both locations half the time. They're kind of blinking on and off like a Christmas tree light. And when you draw a Lewis dot structure, in order to represent that, you have to draw 2 structures. Or you could draw one structure and show the bond that's there half the time with a dotted line, and I'll show that in right now. Alright, but before I show that, I want to just go over a different way of doing it that might make things a little easier, because here, it's kind of confusing. Do I put the double bond here? I got these 2 single dots. So I'm going to count all of the valence electrons that I have. I've got 6 for sulfur and 6 for both of the oxygens. So 6 times 2 is 12 plus 6 is 18. So I'm going to rewrite this molecule, and each atom needs to be bonded with 1 bond. So we have 1, 2, 3, 4 electrons in those 2 bonds. And then I'm going to add electrons to my outer atoms until they have 8 valence electrons. And if I have any extra left over, they get added to my sulfur or my central atom. So I have 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Alright, so oxygen has 2, 4, 6, 8, it's fine. This one has 2, 4, 6, 8, it's fine. But the sulfur has 2, 4, 6, it needs to have 8. So all atoms need to have 8 outer electrons. So in this case, we're going to do some sharing. And you could have 2 electrons from this oxygen share or 2 from this. Half the time, 2 are going to share from here, and the other half the time, 2 are going to share from the other oxygen. And we put it in brackets because it's resonance. Both structures are totally valid, and they're happening at the same time. So it's really a bond and a half instead of a single bond or a double bond. We could also draw this as one structure by showing a dashed line connecting to them, connecting the oxygen to the sulfur. So it's showing 1.5 bonds, or 1 bond and one that's there half the time. Alright, deciding if this is symmetrical, we'd have to see if we can cut it in half. So if we cut this in half, it's not symmetrical from top to bottom, because we'll find out that this is bent. So we would say no to symmetry, and if it's not symmetrical, then we would call it polar. Alright, moving on to another problem. We have PO4 with a 3 minus charge, and I'm going to do this the counting way. We have phosphorus over here is in 5A, so it has 5 outer electrons. And we have oxygen, which is right next to phosphorus, has 6 outer electrons. and there are 4 of those. And then it has a 3- charge, which means we have 3 additional electrons. We're going to add 3 more. So 6 times 4 is 24, plus 5 is 29, plus 3 is 32. So I'm going to write this. P is in the center because it's in least supply. We have 4 oxygens. So each one has to have at least one bond connecting them to from the outer to the center atom. That's 2, 4, 6, 8. I'm then going to add electrons to my outer electrons first. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, and it works out perfectly. Count all of them out. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, and 2, 4, 6, 8. Every atom has a satisfied octet. The last step, since it's a polyatomic ion with a charge, put the whole thing in brackets, and we put the charge outside of it. And that's going to be the Lewis dot structure of phosphate. Alright, doing another problem, the one that's not on this sheet, it's NH4+. So we have something like this. It's another polyatomic ion. Nitrogen has 5 outer electrons, and hydrogen has 1. So we add 1, but there's 4 of them. And in this case, it's positive, so we're actually losing an electron. We're going to minus 1. So it's 4 plus 5 is 9, minus 1 is 8 electrons we're dealing with. Nitrogen's going to be in the center because it's in least supply. It's 1, 2, 3, 4. Well, actually, we're not doing that way. We have to definitely have at least one bond between the H and the N. Alright, and we have 2, 4, 6, 8, and we're set. They're all satisfied. Hydrogens are satisfied too. They're the exception. Instead of having 8, they want to have 2. It's because to fill that 1s orbital, you need 2 electrons, and you have it. But since it has a charge, you have to put the whole thing in brackets and put the positive charge outside of it, and that is NH4 ammonium. Alright, doing another problem. Let's do it from this first worksheet. We have CO3 with a 2- charge, and carbon, it's 4A, has 4 outer electrons. 4 plus oxygen is 6, and there's 3 of them, and it's a 2- charge, so we're adding 2 electrons. 6 times 3 is 18, plus 2 is 20, plus 4 is 24. So we're going to start with carbon in the center because it's in least supply, and we're going to have at least one bond to each oxygen. It gives us 2, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Each oxygen has 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. However, carbon has 2, 4, 6. So there's going to have to be some sharing going on, which means there's some resonance that's happening, some delocalized electrons. So each oxygen could share its 2 electrons. Each one will 1/3 of the time. So these guys will be shared 1/3 of the time. And then we have to put it in brackets and put a 2-. And we have to draw the same picture, only with the double bond on a different oxygen. Got these. And it's in brackets with a 2-. And then one more. And those are the 3 structures. And if you wanted to show all of them on one structure, then you would show it like this with a dashed line connecting all of them at once with a 2- charge. And that would be your resonance structure. Would this be symmetrical? So looking at it, you cut this in half. So it would look as though it is not symmetrical. so you would call it polar. However, resonance is tricky, so it has delocalized electrons. You'd really have to look at the sum of all the Lewis resonance structures, which would be this one. And if we look at this, it is symmetrical, so yes for symmetry, so therefore it would be nonpolar. A lot of times when you have resonance, to really determine whether it's polar or nonpolar, you have to look at the sum of the three structures. And knowing polarity will make more sense when we talk about molecular geometry and the actual shape of the molecule. Alright, let's do one more. We have NO3, the -1 charge, that's nitrate. We'll do it on this side. So, well, we'll just rewrite it. NO3 with a -1 charge. N has 5 outer electrons, it's in column 5A, and oxygen has 6. But there's 3 of them. So multiply by 3, and it has a 1- charge, which means it has 1 additional electron. Add 1. 6 times 3 is 18, plus 5, plus the 1 is 24. Alright. Nitrogen is in the center because it's in least supply. We have at least 1 bond to each of our terminal atoms, O to N. That's 2, 4, 6. We then add electrons to our outer atoms and then to our center. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So each oxygen has 8 outer electrons. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. But nitrogen has 2, 4, 6. So we're going to have to do some sharing again. Each oxygen is able to give 2 of its electrons and share them. And they're all going to do it 1/3 of the time. So you'd have to basically draw 3 structures. And this would be one of them. The other one would be the double bond over here. Minus, and then the third one, the double bond would be towards the bottom. Or you could draw all 3 structures in one. We have minus, and this is the structure you look at when determining whether it's symmetrical or not symmetrical, and this would be symmetrical, therefore it would be nonpolar with a bond length of 1.33. And those are the Lewis dot structures for molecules that exhibit resonance or delocalized electrons, and also polyatomic ions.